Right. So what was the last square? This was the last one. So next concept is determinant. So actually determinant is complete another chapter in algebra. What I will not go in depth of the chapter, just I will explain what is determinant, because the determinant is helpful to find the area of a triangle. Okay, that's why just I will explain that part only. What is determinant, how to calculate, that's it. I will not go in depth. That is another chapter. I will explain in the chapter in detail. So here determinant means, suppose the notation for the determinant is this one. So suppose the determinant is here, suppose A, B, C, D is there. So this determinant is called as 2 by 2 determinant. So this is 2 by 2 determinant. This 2 denotes number of rows. This 2 denotes number of columns. So rows and these are columns. So this is 2 by 2 determinant. Next 3 by 3 determinant, that is A, B, C, D, E, F, G, H, I. So this is another type of determinant, that is 3 by 3 determinant. Here how many rows? 3 rows and 3 columns. So this is the determinant. So how to find the determinant? So to find the determinant, I will explain with examples. Suppose 2 by 2 determinant, suppose 2, 4, 1, 6. Suppose to find the determinant, this determinant, then just this into this, that is 2 into 6, that is 2 into 6 minus 4 into 1. So this is the value of the determinant, that is 12 minus 4. So this is the value of the determinant. So for this one, in generally, for this one, determinant is what? AD minus BC. So this is the 2 by 2 determinant. This is example number 1. Next, 3 by 3 determinant. Suppose 4, 1, 6, 3, 2, 5, 6, 7, suppose some 3. So this determinant, to calculate this determinant, so what you do is, first this is equal to 4 into, here you write here alternate signs, plus, minus, plus, you write like this, plus 4 into, so leave this column, the column which contains 4 and the row which contains 4. Then you take this determinant, that is 2 into 3 minus 5 into 7. So that is the first step. Here 4 into 2 into 3, this into this, minus 5 into 7. Next alternate signs. Next minus of 1 into, now leave this column and this row. The column which contains 1 and the row which contains 1. Leave this one. Next 3 into 3 minus 5 into 6. That is 3 into 3 minus 5 into 6. Next plus sign. So plus 3 into, plus 6 into, plus 6 into, leave the column and this row which contains 6. Then you left 3 into 7 minus 2 into 6. Therefore 3 into 7 minus 2 into 6. So this is equal to 4 into 6 minus 35 minus of 1 into 9 minus 30 plus 6 into 21 minus 12. So this is equal to 4 times. What is this? Tell me. 29. Huh? So this is 29 minus plus 30 minus 9. So what is this? 11? Yes or no? Not 11, 21, sorry. So this is 21 plus 6 into, what is this? 9. So what is 29 4 times? 160 na?
116.
116, right? 116 plus
minus
21. Yes.
It will be minus 116. It will be minus.
Okay, right. Sorry, minus 116. This is minus 29. Yes, this is 54, I think. Yes. Now, what is the final answer? Tell me. Minus 116. This is 75. Tell me what is the final answer? Here 1, 4 minus 41. Is this correct?
Yes, sir.
Yes. This is the determinant. Clear? Right. Next one is right. Next one is in a triangle. In a triangle ABC. In a triangle ABC, let vertices A x1 comma y1, B x2 comma y2, and C x3 y3. X3 y3. Then centroid of triangle ABC is equals to ABC is notation for centroid. Already we have seen G, that is x1 plus x2 plus x3 by 3 comma y1 plus y2 plus y3 by 3. So this is the centroid of the triangle. So why the centroid is this one? So for that one, so in compact form, you can write the centroid as sigma x1 by 3 comma sigma y1 by 3. You can write in compact form like this. Now, so why this is the formula for centroid? We will see. Suppose you take one triangle, any triangle you take. So in this triangle ABC, so this is the triangle ABC. So A x1 y1, B x2 y2, and C x3 y3. C x3 y3. So here we know that what is the definition of the centroid? The point of, in last class we have seen, the point of concurrency of medians. Yes or no? The point of concurrency of medians is the centroid. Means, suppose the median through the vertex A is this one. Suppose this is the midpoint of BC. So this is the midpoint. That is, what is this? X2 plus x3 by 2 comma y2 plus y3 by 2. So this is the midpoint. So this AM is the median, one of the medians. The median which passes to the vertex is this one. Therefore, the centroid is what? The point of concurrency of medians. Means the centroid lies on this median. Yes or no? That is the first thing. Centroid lies on the median because the centroid definition itself is the point of concurrency of the median. So now what you do is, now already we have seen one result. The centroid divides the median internally in the ratio what? Tell me. 2:1. Yes sir. The centroid divides median internally in the ratio 2:1. Means here the centroid G divides A and M internally in the ratio 2:1. So therefore centroid coordinates are, so here A x1 y1, A x1 y1, and M x2 plus x3 by 2 comma y2 plus y3 by 2, y2 plus y3. So the ratio is what here? Suppose M is to N is the ratio, that is 2:1. So 2 goes this side and 1 goes this side. So what is the centroid coordinates? Tell me. G is equals to mx2 plus nx1. That is 2 into internal division formula. 2 into x2 plus x3 by 2 mx2 plus nx1. So n is what? 1. X1 is x1 itself. Over m plus n, that is 2 plus 1. Comma Next my2, that is 2 into y2 plus y3 by 2, my2 plus ny1, n is 1, y1 is y1 itself, by 2 plus 1. So this is equal to, centroid is equals to, so this 2 to cancel, here also 2 to cancel. Just here you left with what? x1 plus x2 plus x3 by 3, comma, y1 plus y2 plus y3. So this is the proof. Okay, na? This is the proof. Therefore, centroid is x1 plus sum of the x coordinates by 3, comma, sum of the y coordinates by 3. This is the centroid. Next, now we will see general strategy to find centroid, circumcenter, and orthocenter and incenter. Yes or no? We have seen these 4 definitions in last class. So what we do is, suppose this is the triangle. So this is the triangle ABC. This is A and B, C. So now what I do is, now suppose this point is D. This point is D. Suppose this is some K. This K divides A and D in the ratio lambda is to nu. So now here I am not giving any name to this AD, just AD only. So just D is the point on BC line. So here K divides AD in the ratio lambda is to nu. I have not given any names. Now here this K may be centroid or incenter, centroid or incenter, comma, circumcenter or orthocenter. So these many we have seen. So now what you do is, first point is, we require BD is to DC. Is that no? This is BD is to DC. So with the help of, now BD is to DC, with the help of BD is to DC, then you calculate the coordinates of D. Yes or no? So now first one is, we require what? BD is to what? DC. So with the help of this one, find the coordinates of what? D. Second one is, with the help of this AK is to KD, you find the value of K. Find the value of K. Okay, now. So this is the first one. Next one is, I will give the orthocenter and circumcenter all the formulas here. Just I will give the formulas here. Again, the proofs of all the formulas you will learn in properties of triangle or solution of triangle chapter. Time being, just I will give the results. That's it. So first one is orthocenter. Orthocenter proofs you will learn in properties of triangle. So orthocenter formula is x1 tan A plus x2 tan B plus x3 tan C over tan A plus tan B plus tan C, comma, y1 tan A, y2 tan B, y3 tan C by tan A plus tan B plus tan C. tan A plus tan B plus tan C. So this we can write in compact form sigma x1 tan A by just sigma tan A, comma sigma y1 tan A by sigma tan A. So already we have seen in a triangle ABC what is sigma tan A. We proved there in trigonometric ratios, in transformations. We proved what is sigma tan A. Sigma tan A means what? Tan A plus tan B plus tan C. So in trigonometric ratios and identities, we proved this one. Tan A, if in a triangle ABC, tan A plus tan B plus tan C is nothing but what? Tan A into tan B into tan C. Yes or no? So that is sigma tan A is nothing but pi tan B. Pi means product, that is tan A into tan. I have written this tan A, tan B, tan C in compact form as pi. Here pi is not a number, just the notation to denote product like sigma. Here sigma is for summation, pi is for product. This is not irrational number pi in this context. Yes or no? So pi means product, that is pi tan A means tan A, tan B, tan C. So that we have seen in trigonometry. That's why sigma tan A you can replace with pi tan A according to our requirement. So both are same only. So similarly, sigma y1 tan A by pi tan A. You can write like this also. Since from trigonometry we proved this one. Sigma tan A is equal to what? Pi tan A. Both are same. So this is the first one. So next, this is what orthocenter formula. Memorize all these formulas. You make a list of the formulas and memorize. If possible, I will give the list of the formulas. I will keep in website. You can collect from there. So next one is circumcenter. Circumcenter formula is sigma x1 sine 2a. Just I am writing in compact form by sigma sine 2a. That is x1 sine 2a plus x2 sine 2b plus x3 sine 2c by sine 2a plus sine 2b plus sine 2c. So sigma y1 sine 2a by sigma sine 2a. Sigma sine 2a. So this is the formula for circumcenter. Just a minute. So next one is incenter. Next one is incenter. Incenter. So incenter is the formula for incenter is sigma a x1 by sigma a y1 by sigma a. This is the formula for incenter. If you open this compact form, ax1 plus bx2 plus cx3 by a plus b plus c, comma ay1 plus by2 plus cy3 by a plus b plus c. So this is the incenter formula. So here in incenter, so here what are ABCs? ABCs are the, already we have seen, I have given the notations initially. ABC means this length of BC is small a, length of AC is small b, length of AB is small c. A x1 y1, B x2 y2, x3 y3 are vertices. So A x1 y1, B x2 y2, C x3 y3. These are the vertices. So if you know the vertices, then we can find the lengths of the side. Then you put those values in this one, then you will get the incenter. So this is the formula for incenter. Next, excenter. Excenters, because 3 excenters will be there. Sir. excenters. So excenters, 3 excenters will be there. So here I1, in last class we have seen the definition. I1 excenter is minus AX1 plus BX2 plus CX3 by minus A plus B plus C, minus AY1 plus BY2 plus CY3 by minus A plus B plus C. So this is the excenter opposite to the vertex A. This is excenter opposite to vertex A. That is in diagram we have seen. In last class we have seen excenter. So this is the excenter opposite to vertex A. Suppose this is A. So opposite to vertex A means, so this is the X circle. This is the X circle. So this is I1 opposite to the vertex A. Yes, sir. So this is the triangle. This is the vertex opposite to vertex A. This is the excenter I1. Similarly, I2, by symmetry you can write I2. For I2, here you will have minus. For I3, here you will have minus. That's it. It is easy to memorize also. So I1 is similarly AX1 minus BX2 plus CX3 by A minus B plus C, comma, AY1 minus BY2 plus CY3 by A minus B plus C. So this is the excenter opposite to vertex. What? B. So excenter opposite to vertex B. Similarly, I3. I3 is AX1 plus BX2 minus CX3 by A plus B minus C. AY1 plus BY2 minus CY3 by A plus B minus C. So this is the excenter opposite to vertex C. You can write it. Clear? These are the formulas. So next what I do is to memorize all the formulas. So I will write all the formulas in one formula. So that is, it is easy to memorize. First you write this one, that is lambda 1 x1. When you write lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 over lambda 1 plus lambda 2 plus lambda 3, comma, lambda 1 y1 plus lambda 2 y2 plus lambda 3 y3 by lambda 1 plus lambda 2 plus lambda 3. So here, for in this one, first point, for centroid, lambda is equal to what? 1. If you put lambda is equal to 1 in this one, you will get the centroid formula. Yes, sir. X1 plus lambda is equal to 1 means lambda 1, lambda 2, lambda 3, all. So lambda is equal to 1. Otherwise, you will write like this. Lambda I is equal to 1, where I is equal to 1, 2, 3, like this. So here lambda, just you memorize like this. Lambda is equal to 1. Then you will get the centroid formula. Second one, for orthocenter, you memorize like this. Lambda 1 is equal to tan A. Just first one you memorize. Lambda 1 is equal to tan A means lambda 2 tan B, lambda 3 tan C, because in a triangle ABC. So third one is circumcenter. For circumcenter, just you memorize this one. Lambda 1 is equal to what? Sin 2A, etc. Next, fourth one, for incenter, lambda 1 is equal to A, lambda 2 is equal to B, lambda 3 equal to C. So like this, you can memorize this center, centroid and orthocenter, circumcenter and incenter. Is it clear?
Yes, sir.
Right. Now we'll solve few questions. Question number 1. If 0, 1, if 0, 1, 1, 1, and 1, 0, and 1, 0 be the middle points of middle points of the sides of a triangle, then find its in center, So here rough diagram will draw. Suppose this is the triangle. So in coordinate geometry, what you do is, whenever you require the fair diagram, then only you draw the fair diagram. Otherwise, just you solve the problem with the help of rough diagram only. Means rough fair means you don't to draw the fair diagram. What we do generally, we will take the coordinate axis reference frame. We will take in that reference frame exactly. We will put the locations of the points. Then we draw the diagram. That is the fair diagram with the help of reference frame. So sometimes we cannot solve the problem by rough diagram. We need to solve the problem with the help of fair diagram only. So in those situations only you draw the fair diagram. Otherwise you solve the problem with the help of rough diagram only. Don't waste much time on exact diagram. So here fair diagram is not required. So here I will take the points as 0, 1. So 1, 1 and 1, 0. So here middle points of the side, sorry, these are not the vertices. Middle points of the sides here are given. So this is A, this is B, this is C. So first middle point of side AB, suppose 0, 1. Suppose this is the middle point. And middle point of the BC is suppose 1, 1. Next middle point of AC is suppose 1, 0. Then what is being asked? Find the in center of the triangle. So first before finding the in center, to find the in center, we need the vertices A x1 y1, B x2 y2, C x3 y3. Because so what is the in center formula? To find the in center, we need what? Length of the in center is this one. So length of the sides of the triangle we need, the vertices we need. So no. First we find the vertices, then of the length of this sides, then you put in this one. So this is the formula, in center formula. So what we do is, this will keep. So this is our formula. First we need to find the x1, y1, x2, y2, x3, y3. To find the x1, y1, x2, y2, x3, y3, we need the midpoint formula. This is the midpoint of AB. This is the midpoint of BC, etc. So first one is x1 plus x2 by 2 is equal to 0. So from this one, x1 plus x2 is equal to 0. This is the first one. Next one is y1 plus y2. y1 plus y2 by 2 is equal to 1. So from this one, y1 plus y2 is equal to 2. y1 plus y2 is equal to 2. This second one. Next one is what? x2 plus x3 by 2 is equals to 1. That implies x2 plus x3 is equal to 2. Next, y2 plus y3 by 2 is equals to again 1. That implies y2 plus y3 is equals to 2. Next, Third one, x1 plus x3 by 2. So x1 plus x3 by 2 is equals to 1. That implies x1 plus x3 is also equal to 2. Next to y1 plus y3 by 2 is equals to 0. That implies y1 plus y3 is equals to 0. So we have 6 equations and 6 unknowns. These are 6 equations and 6 unknowns. So you can solve. So to solve, what you do, you add these 3 equations. Then what you get, 2 times x1 plus x2 plus x3 is equals to 4. That implies x1 plus x2 plus x3 is equal to 2. Next, here also you add, here you add these 3 equations. Then what you get, 2 times y1 plus y2 plus y3 is equals to again 4. So y1 plus y2 plus y3 is equals to what? 2. So now what we do is, now we need to find what? x1, y1, x2, y2, x3, y3. For that one, what you do? You put x1 plus x2. From this one, you put x1 plus x2 over here. Then from that one, x3 is equal to what? 2 we got. So put x3 equal to 2 in the second one. That is x2 plus x3 is equal to 2 in this one. x2 is equal to what? 0. Now put x2 and x3 again in last one. Then what you get? 0 plus 2. Therefore, x1 equal to 0. Clear this one? Is it okay? Is everything
Yes.
fine? Right. So similarly, you will find here y1 plus y2 is equal to 2. Therefore, 2 plus y3 is equal to 0. y3 is equal to 0. Now put y3 equal to 0 in this equation. Then you will get y1. Therefore, y1 plus 0 is equal to 0. So y1 is also equal to 0. Next, y1 0, y3 0. So y2 is equal to what? 2. So now we locate the vertices. Now tell me, so this is the triangle. So a x1 y1, x1 is 0. What is y1? y1 is 0. B x2 y2 is what? x2 is 0. y2 is 2. C x3 is what? x3 2, y3 0. So these are the vertices. Now what we need here, these are x1 y1, x2 y2, x3 y3. We need the lengths of the sides. Now what is this distance? Tell me. So BC distance equal to what? Distance between 2 points. Yes or no?
2
That
root
is
2.
2 minus 0 square plus 2 minus 0 square. That is equals to what? 8 or 8. That is 2 root 2. That is this length, that is A is equal to 2 root 2. Similarly, AC distance is equal to what? Distance between 2 points, again 2 minus 0 whole square plus 0 square only, 0 minus 0 whole square, that is equals to 2 only. So this distance equal to 2. What is this? Small b is equal to. Similarly, AB is equal to what? Again 0, 0, 0, 2. Therefore, this is also equal to 2. Okay? C distance. Clear?
Clear, sir.
Yes.
So I is equal to what? Inside, just you put the data in the formula. This AX1 will be used. So formula is what? AX1. A is what? 2 root 2. AX1. X1 is 0. AX1 plus AX2. See, AX1. Oh, sorry. AX1 plus BX2 plus CX3. AX1. So BX2. B is what? 2. X2 is equals to 0 plus CX3. C is equal to 2. X3 is equal to again 2 by A plus B plus C. So A plus B plus C is what? 2 root 2 plus 2 plus 2. Next one is yes, AY1 plus BY2 plus CY3. AY1, BY2 plus CY3. AY1. AY1 plus BY2 is what? 2. Y1, Y2. AY1, BY2 plus CY3. c is equals to 2, y3 is equals to 0 by a plus b plus c, that is 2 root 2 plus 2 plus 2. So that is equals to, now this is 4 by, tell me here 4 plus 2 root 2, comma, here what you 4 by, here also you will have the same thing, that is 2 root 2 plus 4. So you take out 2 common and cancel out, then what you get, 2 by 2 plus root 2 by 2 by 2 plus root 2. Okay, na? Clear? Coordinates of in center. Next question is,